Hi, I'm Mishari Muqbil. I am the moderator and speaker for this session. Thank you. So this started off with me getting involved in OpenStreetMap. I was a big fan of OpenStreetMap, collecting data, adding data into the world's largest open map project. And then from that point on, I decided that it was fun to run some analysis using OpenStreetMap data. So I was playing around with OpenStreetMap and sharing information, the results of my analysis on Twitter. Then I got into a Twitter argument with this guy who has an account about transit in Thailand. He then asked me to come and join in a team who was helping out the deputy governor of Bangkok in doing urban planning and related work. So that's how I got involved with this project. Now, it's very interesting because after that, it resulted in this publication, this conference presentation, called Convenient Walking and Safe Cycling, and it's active mobility for the healthy city. So in Bangkok, we have an area that is very similar to the old quarters here in Hanoi. It's the oldest part of Bangkok. It's called Bamrung Mueang. And you can see it from the screen over there. The purpose of this is to try to see what we can do about the problem of traffic and all the other problems that comes with having cars on the road. And so we had a hypothesis, right? What if we made the roads easier for people? If people can come and start using the roads, if we started reducing the amount of space that was dedicated to cars and increasing the convenience for humans. If we design for humans, will more humans come? Will there be less cars, right? Because I don't know, who here has been to Bangkok? Anyone here been to Bangkok? One person in the back. Two, thank you. So just to tell you how bad the traffic is in Bangkok, last week a friend of mine was coming to a party. They were 1 kilometer away from the party venue. They sent a message into the group room, hey guys, I'm 1 kilometer away. 3 hours later, they sent another message, I moved 300 meters. 3 hours, 300 meters in 3 hours. That's how bad the traffic is can be in Bangkok. So, why do many people drive? Because they don't have much choice. There's no space for people to walk, and so they drive. But what would happen if we can make space for people to walk? Will people still choose to drive because it's hot? Or will they decide, no, we want to walk? So this project started off with talking to people, the people in the neighborhoods, because the team who did this did not want this to be a top-down affair. They wanted to get the opinions of the people in the neighborhoods as well. And so there was some data collected initially. Now, you can see that this was quite interesting. The 70% of the people only commuted 0 to 5 kilometers every day, which is very much walking or even cycling distance, right? In the bottom, we can see that the other interesting thing, people who drove had the most number of NCDs. I think it's non-communicable disease. Basically things like diabetes, heart problems, etc., etc. So 36% in cars, 31 for motorcycles, 29 for taxis and walking, and 0 for bicycles. Of course, it has a lot to do with the data size and the demographics as well. But it's interesting nevertheless. The other thing that we see is that the people who drive spend the most amount of money every month. So that's a huge cost, right? While the people who cycle spend the least amount of money. So here are some photos. I think parts of it will remind you of Hanoi. You can see over there, narrow sidewalks, huge open intersections that is almost impossible to cross, and shops blocking the sidewalks. And so there were a bunch of studies done, right? This is very much data-driven. So there was an analysis on the road accident rate. We did a traffic simulation, urban morphology study, and we pulled in a whole bunch of data. And so out of that, it was decided to do the following treatment, right? It was decided to increase the amount of surface that is available for the pedestrians, make the pedestrian crossings more visible, and add in bollards in order so that people can walk more easily. And this design was again taken back to the community. So out of that, 93% said that they agreed with the design, and then 66% said that they would walk more. So far so good. And this is some example of the treatments done. This is a Dinshaw, right? The neighborhood. So what you see up there used to be a parking lot. So they had put in, what's the word? Barriers, metal barriers, which then was upgraded to a bollards. So this is practically unheard of in Bangkok, right? Because it would always be in how do we improve the flow for cars? But for the first time in Bangkok, it has been, okay, we are going to basically say, forget about the cars for now. Let's try to improve things for humans. And so that is what has happened. And in Mahanop Road, we can see there was a lane reduction, curb extension. What that means is that we make the curbs narrower. You can see the image at the bottom. So there's less space that you need to cross over and have to deal with the cars. And when you make the turn circles narrower, then the cars have to slow down as they approach, which makes it safer for pedestrians. All right. Remember, from 1970s, everything was about how to make the cars go as fast as possible in Bangkok. Again, the Tiger Shrine intersection, huge red markers on the crossing so that the pedestrians can cross more easily. The cars can see that there is a crossing. Tanao as well, creating a lane markers so that people can walk. Sometimes it doesn't actually have to be a physical thing. Sometimes it is only a psychological. So if the cars can see a line, then they move away from it and make space for humans and cyclists. More changes. I will skip through this. This is another concept in Bangkok, a road diet. So rather than increasing the number of lanes, they actually reduced the number of lanes and provided parking space. So again, the narrower the lanes, the slower the cars go. The slower the cars go, the safer people feel. So let's go to the data. These are the results. You can see before and after treatments. So the number of pedestrians went up from 21,000 people to 25,000 people. And in some cases, you can see, if, for example, Tanao Road, the third one down, went up from 2,950 to 6,000 people walking along those roads. And there was some of the roads here were controlled as well, which means that it's in the control roads, the numbers were unchanged. However, in the ones where we performed an experiment, the number of people walking went up by 100% in some cases, which shows that really if you design for people, people will start coming. And here's some more information there. So the motor vehicles, they continue to go up. However, pedestrians went up significantly, and the number of cyclists also went up. So again, it seems like if people see that a road is safe, they will use it. If cyclists see that a road is safe, they will use that too. Motor vehicles still continue to be mostly the same and same number, and that's kind of okay as long as there's alternatives for other people. Yeah, there we go. On Mahanop, pedestrian volume increased from 2.8 thousand to 3.7 thousand. And on Tanao Road, it went up from 2.9 thousand to 6,000. So there seems to be a correlation, right? These numbers are very, very, very preliminary, of course, because of the data size, etc., etc. However, it seems that the slower you make the traffic on the road, the safer people feel. And the safer people feel, the more likely they are going to use that road for walking or cycling. And I suppose that that is a very good way of reducing or eliminating the traffic problem in any city, because as soon as you get rid of the cars, or as soon as people choose not to use their cars, traffic goes away miraculously. And for a city like Bangkok, where there's something like 4 times as much cars as road capacity, this looks like a good strategy. So once we have reduced the cars, what else can we do? Pop-up space. We can reuse those spaces that were formerly dedicated to cars to do various community spaces, right? And recover it and redesign it for humans. And this attracts more humans. And when you attract more humans, it becomes nicer. People like mingling with other people. People like seeing other people walking around. And cars get in the way of that. And as soon as you start taking cars out, then the people come back. And basically what this has started doing is that this has started to revitalize the local economy. So from that, the key takeaways, if you plan for the most vulnerable road users, right? Because humans are vulnerable. Cars are cages of steel that weighs 1 or 2 tons. What if you design your cities to make it safe for humans, people walking, people on bicycles, people in wheelchairs? Then everyone wins. The next thing that we figured out is that it's not just okay to design the road to make it pretty, but then from the data that we gathered, the road has to connect. If the roads connect, then as a network, people will flow through those connecting points. There's a strong correlation between the change in number of pedestrians. So as I said, the slower you make the cars, the 25 kilometers per hour is the sweet spot. If you can reduce the cars so that the speed of the cars so that they go slower than 25 kilometers per hour, people will feel safer to walk on those streets. And if you build it with the proper infrastructure, they will come. So big thanks to the folks at the Thailand Walking and Cycling Institute Foundation who put this together. It was a fine piece of research that was done in Bangkok using a lot of open technology that thankfully is now available for anyone to use. It's miraculous because this would not have been possible even 10 years ago. The only reason that it was possible is because of open data and open source software that made all these amazing tools available for doing the analysis and the other work. So very much grateful for FOSSASIA and other communities which has helped fostered the open source, open data movement in this part of the world, because without FOSSASIA and without the amazing people in the open source communities that we have in this region, things like this would not be possible. So with that, thank you everyone for listening.